Section 2.4 and inverse functions, and hopefully we can remember the idea of inverse functions. You know, if you take an input to an output, that would be f. The function that takes the output and maps it back to the input, that would be f inverse. So inputs are usually x, outputs are usually y. So finding inverse functions is where you change the x's and the y's around, right? So let's go straight into the example. If I've got the function y equals 3 over x minus 1, the input is the x and y is the output. Now, the function which takes you the other way round puts the input here where the y is and the output here where the x is. So if you swap your x's and y's, then this is a silly way of writing the inverse function. All I need to do now is take this and rearrange it. So x times y minus 1 equals 3. xy minus x equals 3, y x equals 3 plus x, y equals 3 plus x over x. So that is now the input, that is now the inverse function, okay? Because if x is the input here, y is the output. If x is the input here, y is the output. Well, if x is the input here, y is the output. If I input a y, then x was where it came from. You get the idea. Swap the x's and y's around. Change what was the input for the output, what was the output for the input. Algebraically, that means swap the x's and y's and work from there. Now, when it comes to... So that's one trick that we know about inverse functions. There are sort of three things we need to know. Second one is this. If you have a function on a graph, let's say here, this is the input, the x value, and this is the output, the y value. The inverse function would take you from here back to here. So I put inputs on this axis and outputs on this axis. Now for the inverse function, I make these the inputs and these the outputs. So if I was allowed to plot a function with inputs here and outputs here, the inverse function would look like this, but that's not the way we do it. We need to put the inputs on the x-axis. So in other words, if I've got the function drawn and I want the inverse function, I need to swap the x and y axes around. And if you swap the x and y axes around, what you're really doing is doing a reflection in this diagonal line here, and this diagonal line here is, as you know, the line y equals x. So if you need to sketch an inverse function, if you've got to sketch the function, just reflect it in the line y equals x. So those are the two sort of tricks we can use. Reflecting the line y equals x is how to sketch it. Swap the x's and y's and the inputs and outputs if you need to find an expression for it. I said there were three things you need to know. The third one is, if you've understood everything, this won't come as any surprise really, but it needs to be a one-to-one function. Why does it need to be a one-to-one function? Well, functions either need to be one-to-one or we can be many-to-one, right? So these two things are allowed to be functions. This thing is not allowed to be a function. A one-to-many is not allowed to be a function. That's not allowed. Well, let's imagine going backwards. This one, if we go there, we can go back. If we go there, we can go back. We can go there, we can go back. So that's fine. One-to-one is no problem. Inverse functions, if I've got a many-to-one function though, well, if I started here and I get to here, well, what if I want to go back? Do I go back here or do I go back here? That's not now a function. So if I want to make an inverse function, I need to have a one-to-one function. Now what we often do there is you think, well, hang on a minute, I know that square root of x is the inverse of x squared as an operation. Can't I express that in functions? Well, you can. You just need to restrict the domain. So if you have y equals x squared, it looks like this. If you have y equals x squared for positive numbers, it looks like this. That's now a one-to-one function. So if you just restrict your domain, then you can make yourself a one-to-one function in a lot of cases, and then you can have an inverse. So there we go. I think that is everything we need to know about inverse functions for this chapter.